Class 12th, Subject Physics, Chapter 1, Electric Charge and Field. Today we will discuss about the questions based on 1 marks. Let us see first question. When a charge Q is placed in electric field of intensity E, the force exerted on it. We know that the electric field intensity E equal to F upon Q. Then the force is F equal to QE because this Q is transposed towards it. So F equal to QE. This option is correct. Now second question. The electric field at a distance r from a point charge is directly proportional to. So first let us see the formula of electric field due to point charge. E equal to 1 upon 4 pi epsilon naught Q upon r square. So here this option is correct, 1 upon r square, because this formula contains 1 upon r square. Next question, third question. The electric field at a distance r from the center of an electric dipole, then the electric field due to electric dipole at axial or equatorial position is 1 upon 4 pi epsilon naught p upon r square for equatorial and 2p upon r cube for axial position. So the electric field due to dipole will be 1 upon r cube. This option is correct according to the formula. Next, fourth question. The electric field at a distance r from a charged wire is directly proportional to. First let us the formula for electric field due to charged wire is E equal to lambda upon 2 pi epsilon naught r. So E is inversely proportional to r. Hence C option is correct. Next, the electric field inside a charged hollow sphere. The electric field inside a charged conductor is always 0 because the charge given to the conductor are distributed over the surface of the conductor and no charge contains inside the conductor. Next, 6 number question. An electric dipole is placed inside a hollow sphere. The electric flux associated with it will be, so it will be 0 because the net charge on a dipole is 0. 7th question. The value of elementary charge is that the value of elementary charge, that is charge on electron, is 1.6 into 10 power minus 19 coulomb. Question number 8. Electrons in 1 coulomb charge is, so 1 coulomb charge contains 6.25 into 10 to power 18 electrons. This is correct option. Question number 9. Electrons in 1 microcoulomb charge is, then it is 6.25 into 10 to power 12. Here power is 12 and here power is 18 because this is the microcoulomb. It means 10 to power minus 6 is multiplied to it, which is converted into 10 to power 12. 18 is converted into 10 to power 12 due to 10 to power minus 6. Next, question number 10. Who named the charges? Benjamin Franklin named the charges. So correct option is A. Question number 11. SI unit of electric field is, the SI unit of electric field is Newton per coulomb because E equal to F upon Q. So the unit of force is Newton and unit of charge is coulomb, hence its SI unit becomes Newton per coulomb. Next, question number 12. Dimensional formula for electric field intensity is, so we can derive dimensional formula from this formula. We know that E equal to electric field intensity equal to F upon Q. F is a force and its dimensional formula is mlt minus 2, whereas the dimensional formula for charge is at. Now it becomes m l. The power is increased in minus in t, that is t minus 3, because power of t is 1, and when it is transposed to numerator its power becomes minus 1, that is minus 2 minus 1 becomes minus 3, and a is also transposed to numerator, then its power becomes a minus 1. This is the dimensional formula for electric field intensity, and it is corresponding to option A. Now question number 13. Angle between conductor and electric field lines is, electric field lines are always perpendicular to conductor, so its angle is 90 degree. In question 15, electric flux passing through unit charge kept in vacuum. So according to Gauss's law, the electric flux passing through a surface is Q upon epsilon naught. When charge is unit, then the value of Q becomes 1, and the Gauss's law becomes 1 upon epsilon naught. Hence correct option is A. Now question number 16. The work done in rotating an electric dipole 180 degree with the direction of the field in a uniform electric field E will be, so that is E 2pe, where P is electric dipole moment and E is electric field intensity. When it rotated about 180 degree, then its work done becomes 2pe. In question number 17, the edge of cube is x and a charge q is located at the center at a distance x upon 2. Then the electric flux coming out it will be. The electric flux passing through the cube is q upon epsilon naught according to Gauss's law. It has 6 surfaces, so it divided to 6 faces. So we divide it by 1 upon 6. Hence it becomes q equal to 6 epsilon naught. In question number 18, if a positively charged rod is touched to an uncharged conductor, then the charge on the rod will decrease because some charges is moved towards the uncharged conductor. Now question number 19. The surface S is placed parallel to the electric field E. The electric flux bound to it will be 0, because in the direction of electric field the electric flux is always 0. In question number 20, a force F is exerted between 2 point charges placed in vacuum. If a copper plate is placed between these charges, then the force will be 0, because the formula for the force is F equal to 1 upon 4 pi epsilon naught q1 q2 upon r square. When a medium is placed between the plates, then its formula becomes K. For copper plate, K is infinity. The dielectric constant for copper is infinity. When anything is divided by infinity, then it becomes 0. Then thus force acting between the point charges will be 0. Now in question number 21, a hollow sphere of radius 2 meter is given a charge of 10 microcoulomb. The intensity of electric field at its center will be. So we know that the electric field inside a conductor is 0, so the center will lie on the inside the sphere, so its electric field is 0. Now question number 22. There are two parallel metal plates having plus q and minus q charges. If this system is immersed in a tank of kerosene, then the intensity of electric field is. Intensity of electric field decreases because the electric field intensity is inversely proportional to the dielectric constant of the medium. Now in question number 23, a charge q is enclosed by a sphere of radius r. If the radius is doubled, then the external electric flux will remain same. Question number 24. The distance between 2 point charges is r and the force is F. If the distance between them is doubled, then the force will be. Now we will calculate for force. The force, Coulomb force, is equal to F equal to 1 upon 4 pi epsilon naught q1 qt upon r square. Now by the condition, the distance between them is doubled, r is doubled, it means we put 2r, and now we do its square. Hence when square is opened, it becomes 4r square. Thus this formula can be written as q1 q2 upon 4r square. With constant, this constant will be lie at here, so here it becomes 1 upon 4 times, that is force becomes F upon 4. In question number 25, electric dipole placed in non-uniform electric field will work on force, torque, both. When electric dipole placed in non-uniform, then force and torque both work on it. Now fill in the blanks. Questions are here. First questions, the charges are differentiated due to fill in the blanks property, due to polarity. Atoms is electrically fill in the blanks neutral. When there is a decrease in the electron of an atom, it becomes positively charged. The basic reason for getting charge is the transfer of electrons. The charges present in electron is called basic charge or elementary charge. The total charge of an isolated system always remains conserved. Charge is a scalar quantity. 1 coulomb is equal to the 3 into 10 to power 9 ESU, electrostatic unit or state coulomb. The SI unit of charge is coulomb. The dimensional formula for charge is AT. The CGS unit of charge is static coulomb. Next, question number 12. The charge is detected by gold leaf electroscope. Gold leaf electroscope works on the principle of repulsion. The electropermittivity of vacuum is 8.854 into 10 power minus 12 coulomb square per Newton meter square. The dielectric constant of air is 1. The dielectric constant of metal is infinite. Sharing of charges with earth is called earthing. Unit positive charge is called test charge. The magnitude of test charge is 1 coulomb. Next questions. Question number 20. Coulomb's law is compatible with the Newton's third law. The electrostatic force is strong in comparison to the gravitational force. The field around the charge is electric field. Next question. The field around charge is called electric field. Question number 23. The intensity of the electric field is a vector quantity. Question number 24. If a medium is placed around the charge, the intensity of the electric field will be decreased because electric field is inversely proportional to the dielectric constant or dielectric medium. Next 25 questions. Question number 25. The intensity of electric field near a charge sheet is uniform. The energy stored per unit volume of electric field is 1 upon 2 epsilon naught E square. The electric field inside a charged conductor is 0. Electric field lines never intersect to each other. Electric field lines are perpendicular on the surface of the conductor. Electric field lines do not form closed loops. Next question, question number 31. Electric field lines are continuous. Electric lines of force in uniform electric field are mutually parallel. A system of two opposite charges of equal magnitude placed at a short distance is called as electric dipole. The value of electric flux coming out of the unit positive charge air is 1.129 Newton to power 11 Newton meter square per coulomb square. You can calculate by the Gauss theorem, that is phi equal to Q upon epsilon naught. The value of Q is 1 for unit charge and epsilon is 8.854 into 10 to power minus 12. When you will solve, you get this value. The value of electric flux coming out 1 microcoulomb charge. Here is microcoulomb, so this will decreases by 6 power. This is 11 and it decreases to 5 when microcoulomb is placed. Question number 36. The electric flux coming out of 2 coulomb charge is, then it becomes, this value becomes 2 times because it is for unit charge and this is for 2 coulomb charge. Question number 37. 2 point charges plus q and minus q are located at distance L. The dipole moment will be q into L because the dipole moment is the product of magnitude of charge and distance between them. So it becomes q into L. The net charge of an electric dipole is 0. The electric dipole E, electric field axial position is equal to 2 times electric field equatorial position. Now next question, this is the matching of column. So first of all we see here Coulomb's law. Coulomb's law, the formula for Coulomb's law is this. Electric field, the formula for electric field is this, F upon Q naught. Dipole moment, the formula for dipole moment is Q into 2L. Quantization of charge is, this is Q equal to plus minus NE. Torque on a dipole, this is PE sin theta. Gauss's law, this is Q upon epsilon naught. Electric field due to charge sheet, this is sigma upon epsilon naught. Now next question for match the column. Again this is physical quantities and these are the units. Electric field Newton per coulomb, dipole moment coulomb meter, electric flux Newton meter square, torque Newton meter, charge coulomb. Now these are the questions for 1 marks. Why is an atom electrically neutral? The number of electrons and number of protons in an atom are equal, so atom is electrically neutral. Next question, how to find the direction of electric field from electric force of line? The tangent drawn at any point on the electric force line expresses the direction of the electric field. Question number 3. Draw Q greater than 0 positive charge electric lines of force. For Q greater than 0, it means it will be positive charge. and when positive charge placed at a point, then the electric lines of force emerges such that the direction is outside this and this figure. Now question number 14. Question number 4. Q1 Q2 greater than 0, draw electric lines of force for the system like charges. So here Q1 Q2 is greater than 0, it means both charges have same sign, that is plus plus or minus minus, and this is the electric field lines. Now question number 5. Why do electric lines of force form an open curves? Because they start from the positive charge and end at negative charge, so they form open curve. Question number 6. Write the dimensional formula and SI unit for electric dipole moment. The dimensional formula for electric dipole moment is m0 LTA and the SI unit is Coulomb meter. You can also find through the formula, that is Q into 2L. The unit of Q is Coulomb and unit of length is meter, so its SI unit is Coulomb meter. Also the dimensional formula for Q is AT and dimensional formula for L is L. So ATL, LTA you can write in this way. Question number 7. Write the direction of electric dipole moment. Its direction is from negative charges to positive charge along the electric dipole axis. Question number 8. Write the vector form and SI unit of moment of an electric dipole placed in a uniform electric field. The direction of moment of electric dipole is tau vector equal to P vector cross E vector, and its SI unit is Newton meter. Now question number 9. Write the SI unit of dimensional formula of electric flux. The SI unit of electric flux is Newton meter square per coulomb and its dimensional formula is mL3 T minus 3 A minus 1. Next question, question number 10. Write an example of electric dipole. The example of electric dipole is HCl. You can write it that H plus or Cl minus separated for small distance. When a glass rod is rubbed with silk plus 3.2 into 10 power minus 16 coulomb charges come to glass rod, then how much charge will be generated in the silk? The same charge will generate in the silk but in negative sign. Question number 12. What will be the electric flux coming out of a closed surface when electric dipole is kept inside? The electric flux will be 0 because the electric dipole has net charge 0. Question number 13. Some charges are located inside a hollow sphere. If its radius is halved, what will be the electric flux coming out of it? It will remain unchanged because it does not depend on the shape, but it depends only on the charge located inside the surface. In question number 14, if the distance between 2 point charges is halved, what will be the effect of the force acting between them? The force will increase 4 times because F1 upon 4 pi epsilon naught Q, Q1 Q2 upon R2. The distance is halved, so it is written as R upon 2 square, and if this square is open, then it becomes R square, and this 2 goes up to numerator and it becomes 4, so force becomes 4 times. Question number 15. For which type of charge group the electric field intensity is inversely proportional to the distance? So charge linear conducting wire because E equal to lambda upon 2 pi epsilon naught R. Next question, question number 16. An electric dipole is placed in uniform electric field. How much force will act on it? 0, because only torque will act on it. In uniform electric field, no net force act on in a dipole. In question number 17, what will be the intensity of the resultant electric field exactly between two equal and like charges located at some distance? 0, because the intensity of electric field in between both charges will be equal and opposite. In question number 18, draw the electric lines of force for the charged cylinder. Then this is electric lines of force for charged cylinder. Now question number 19, draw electric lines of force for a uniform electric field. These are the parallel to each other. Now question number 20, draw electric field lines for dipole q1 q2 less than 0. That is for unlike charges, this is the electric field lines and the direction will be from plus q charge to minus q charge. So next video will coming soon for 2 marks question in same chapter. Thank you.